This video will be on section 6.2, rate of change and the difference quotient. There are just two topics in this section. First one is the average rate of change. We'll actually see that it's very similar to the slope of a line formula. And then the difference quotient, which is a special average rate of change, but instead of getting a number like you would with the slope, and we will at the average rate of change, we'll get a function. But as far as the difference quotient goes, it's really nothing more than simplifying things that we've already done just in a specific formula. Right, so to begin this section we start by defining the average rate of change of a function. The idea is very similar to the following, the average rate of change. Let's say you're in your car and you drive 200 miles in your car over the span of 4 hours, not worrying about how fast you're going at one specific time, whether you're in traffic or not. The average rate of change is 50 miles per hour, your average speed, because you just do the 200 divided by 4, you went on average 50 miles per hour. Now you could have gone 75 miles per hour the first couple and then hit traffic or something, but that doesn't matter. All that matters is where you start and where you end. All right, so the formal definition of the average rate of change, let x1 and x2 be two numbers in the domain of a function f. Right, this is not to get too technical on you. All this means is that you can actually plug them in. Right, that's what being in the domain means. Then the average rate of change of your function f of x from x1 to x2 is given by f of x2 minus f of x1 over x2 minus x1. So the reason this is so much like the slope is because when we plug in an x value, we get out a y value. So this is like y2 minus y1 over x2 minus x1. So it's very similar to the slope. And we'll just ask this question in a few different ways, using graphs and tables and everything else, just to get a little familiar with it. But once you see it worked once or twice, it's all the same. All right, so this one, we have this graph here, and we want the average rate of change of f from x equals 0 to x equals 4. Right, so the formula for the average rate of change is f of x2 minus f of x1 over x2 minus x1. And if you want, you can label the x values x1, x2. I prefer just to have x2 to be the bigger x value. So if x2 equals 4, we got f of 4 minus f of 0 for x1 over 4 minus 0. Now what is f of 4? Well, that's the y value when x is 4. So f of 4 equals 1. And then what is f of 0? Well, that's where we're looking at where x is 0, which is the y-axis, and the y value is 2. So we're going to plug those in. F of 4 equals 1, f of 0 equals 2, over 4 minus 0, which is 4, and 1 minus 2 is negative 1. And our average rate of change is negative 1 over 4. Right. Now, really what this is finding, you don't need to point this out, draw this in or anything like that, but if we connected these 2 points, the slope of the line would be the average rate of change. All right, one thing you don't want to do, I've seen people do it in the past, especially with a problem like this, is they kind of see that every little section as a line segment. And what they want to do is find the slope of all of the line segments and then find the average. And that's not going to work out for you. pretty much ever. I mean, even if it did work out to be correct, it's way more work. Just use your formula, plug in the correct numbers, and then go with it. All right, the next one is just an example, actually, along with really all these is there's a lot of numbers bouncing around. You just want to make sure you're only using the correct ones. Don't overcomplicate it. All right, so number 2 here, it refers to this table. We want to know the average rate of change of G from x equals 4 to x equals 9. So once again, I'll label x1 and x2. And the average rate of change, very important that you're looking at G, because this one gives us two functions, f of x and g of x, and we only want to use G. Our average rate of change would be g of x2 minus g of x1 over x2 minus x1. x2 is 9, x1 is 4, and now look at your chart to see what are g of 9, what is g of 4. We go where x equals 9 and we see that g of 9 equals 3. And then we go where the x value is 4 and go to the g value there. We see g of 4 equals 7. Once again, just do the same thing and plug them in and simplify our fraction. G of 9 is 3 minus g of 4, which is 7, over 9 minus 4, which is 5. And finally, 3 minus 7, negative 4, over 5. Right. Now, just once again, just pay attention, make sure you're using the correct function here. Yours might ask for f, yours might give you two different names, not f and g. So just make sure you're being careful. Right, the last one here is another table, but instead of having x and y, it's giving you, the table below gives the annual sales in millions of dollars of a product. And what we want to do for this one, it says, what is the average rate of change of annual sales between the years 2003 and 2006? Right, now we don't really have a name for this function, but if we wanted to call it like f, we would want f of x2 minus f of x1 over x2 minus x1. Now the question is which one is x and which one is y? Well, this is where our independent and dependent variables come in if you're ever unsure. We cannot control the year. It just is what it is. So that means it's the independent variable. So the years are the x values or the independent variables. And then the y values are the sales or the dependent variables. The sales depend on the year. So what we have here in words are x2 and x1 would be the years. We got 2006 minus 2003 on the bottom. And then our y's would be the sales in those corresponding years. So in words, it's the sales in 2006 minus the sales in 2003. The sales in 2006 were 293 million, but we only care about the number. The sales in 2003 were 320 million. And the denominator 2006 minus 2003 is 3. And then finally, simplify this. 293 minus 320 is negative 27 over 3, which simplifies to negative 9. Right. Since this is in millions, just as an answer in words, the sales would be decreasing, since it's negative, by 9 million per year on average. And you can see with each of the jumps, it's not necessarily 9. So from 2003 to 2004, it decreases by 3, and then the next jump by 9, and the next one by 15. Like it can be whatever it wants to be in between. Just from 2003 to 2006, it is -9. Right, so a special kind of rate of change, average rate of change, is called the difference quotient. Now, the difference quotient is studied in calculus, but we can do pretty much most of it right now because it's really just function notation. So the formula for the difference quotient is this right here. It's f of x plus h minus f of x over h. Now the reason why this is the same, I wouldn't actually write down what I'm about to write down, but I'm going to show you why this is a rate of change real quick. Average rate of change is if I do something kind of weird to the denominator, replace the h with x plus h minus x. Certainly this is true because the x's can cancel out and we just get the h back on the bottom, so it's the same. And this is sort of like the x2. X plus h is like our x2, and the x by itself is like our x1. So it's the same as our average rate of change with x2 equals x plus h and x1 equals x. Okay, exactly the same as the average rate of change, but like I said, memorize this. You don't need to know that it's the same as a special average rate of change. It's just a good introduction to why it's in this section. This is not how you spell memorize. Now you don't have to memorize it really in words because the way the problems are written is it'll make you simplify this with the formula. It won't tell you find the difference quotient of, it'll tell you figure out this thing. I'll kind of actually forward it. It'll actually tell you to compute this difference quotient for a function. Right, so the way it's going to work, you kind of want to break it down into 3 steps because if you try to do it all at once, that's where mistakes happen. Right, so the first thing will be to plug in and simplify the f of x plus h part. And we know in words what this means is to replace x with x plus h, and then we'll simplify. Right. So that's going to be the first step. The second step, we take our simplified f of x plus h and we're going to subtract off the f of x. Now I do mention here, and because this is what you should see happen, is many things should cancel when you do this subtraction. I'll also mention here when you subtract the f of x plus f of x, what you don't want to do is forget the parentheses. And you'll see what I mean when we work a problem. Right, and then the last and final step, what you ultimately want to do is when you divide by h, so the third step, we have our simplified numerator now, and we want to divide by h. The way we want to do this to simplify is by factoring an h out from the top and then canceling it. The ultimate goal when you when you simplify the difference quotient is to really get that h out of the denominator. And you'll be able to do it on all of them. All right, and we only have two different kinds of functions. We'll do that within this section. And I can just let you see them both right here. Well, I have a linear function. We know what that means now. The highest power of x is just 1. And then the next one is a quadratic function. We haven't necessarily talked about that, but that's when the highest power of x is 2. All right, so it says for the following, compute f of x plus h minus f of x over h and simplify completely. Oh, I'm going to break it down into those 3 steps that I mentioned before. Only do the f of x plus h part first. And we know this means take our formula for f of x and replace x with x plus h. Okay, so visually, once we plug in, it looks like that. Now we distribute the 6 through, and we get 6 times x plus 6 times h plus 3. And this is simplified because there are no like terms. This one has just an x, this one has just an h, this one has neither. All right. All right, so a good general rule of thumb, anytime you plug in x plus h for x, you're going to automatically get a parentheses where you plug it in. You ultimately want to get rid of all the parentheses and combine like terms. This one was just pretty straightforward. So the second step is to complete the numerator, meaning subtract off f of x. What you do, you gotta make sure you take the simplified f of x plus h from before. Actually, let me write the formula part down first. F of x plus h minus f of x. Our f of x plus h simplified was 6x plus 6h plus 3 minus f of x. When you subtract off f of x, put parentheses around your entire thing. So here our f of x is 6x plus 3. And this is exactly what I mean by parentheses. If you forget it, you will not end up distributing the minus to everything, and then you will make a mistake. So do not forget the parentheses. Okay. Now to simplify, distribute the minus through. So we've got 6x plus 6h plus 3 in front. Distribute the minus to the 6x, we get minus 6x, and then minus 3. Okay, and like I said, in this step, many things should cancel. So here, almost everything cancels. We have 6x with a minus 6x and a 3 with a minus 3. In fact, what should happen is everything you subtract over here should cancel with something over here. So we're only left with 6h. Remember, this is the numerator. This is not our final answer. The last step is now to finish. Divide by h. Right, we did the top now. The top is simplified. Now we divide by h. Right, so we take our 6h from before. That's what we plug in on the top. The bottom is h. This one we didn't have to factor out because there's only one thing. We can just cancel the h's. And we're left with 6. And this is our answer. Sometimes it's a number, sometimes it's a function. We'll see with the next problem, it's not always a number, so don't be deceived by that. Okay, the reason this one worked out to be a number, you'll also notice that it worked out to be the slope of this line, is because the average rate of change is the same as the slope. But you can't just look at the front thing, because as soon as we get to number 2, when we don't have a linear function, the average rate of change is not the slope. There is no slope of anything besides a line. But if you follow these 3 steps, the next one is as complicated as it will get. It won't get any more complicated than the next one. All right, so number 2, I'm going to do the same thing. Start with f of x plus h. And this is almost always the long step I'll mention now. We replace everywhere we have x with x plus h. The x squared becomes x plus h squared plus 4, and then x plus h minus 4. Right, so just notice that we had 2 x spots with x here. That's why we had 2x plus h's. And now we have to simplify. We want to get rid of parentheses. And the second one here, since there's no exponent, we can distribute. And the other one does have an exponent on the outside. Remember, the way to do it before is write out what it means to square. We'll end up foiling it. We've done this a few times. We have to do the exponent first. All right, we're just going to leave the negative 4 out front while we take care of the exponent. All right, so the front term here we have negative 4, and then when we square something, that means we want to multiply it by itself. So we got x plus h times x plus h plus, and then the next part we're distributing the 4 through because there's no exponent on the outside. So we got 4x plus 4h. 4 gets taken to both. And then we have minus 4 at the end. With all these 4s, it's tempting to try to cancel out or something like that, but just leave all the 4s alone. You'll see at the end that there will actually be no terms with all this stuff. So now, once again, we've seen something like this before. We leave the negative 4 out front and FOIL first. You're less likely to make a mistake if you just leave the negative 4 out front and FOIL first. So in the front here, FOIL it, we've got x times x is x squared plus x times h, plus h times x, which is h times x, plus h times h, which is h squared. And then just going to bring the rest along for the ride. And now at this spot, you can distribute the negative 4 through. What I want to do first is just look here. These are the same thing. Right, x times h and h times x are the same thing because the order of multiplication doesn't matter. When you add them together, it equals 2 times x times h. Or if you prefer to have h times x, you can have 2 times h times x when we add them together. So I'm going to just write that down first before I distribute the negative 4. Like this. And now is when I'll distribute the negative 4 through. We can have exponents on the inside, we just can't have exponents on the outside, and we do not anymore. So now we distribute. And then when we distribute that to negative 4 to the x squared, we get negative 4x squared Negative 4 to the 2xh, we get negative 8xh. And finally, negative 4 to the h squared, we get negative 4h squared. And then we got plus 4x plus 4h minus 4. And once again, this is the long step. You can see just by adding the squared how much more work it is. Everything else in steps 2 and 3, as long as you do it correctly, are based around simplifying. So remember now, step 2 is to complete the numerator. We take our f of x plus h and we subtract off f of x. And this, like I mentioned before, has no like terms, so this is simplified. We got negative 4x squared minus 8xh minus 4h squared plus 4x plus 4h minus 4. Then we want to subtract off f of x. Let's go ahead and do that. F of x, don't forget your parentheses. We got negative 4x squared plus 4x minus 4. And now it's all about simplifying and canceling like last time. Distribute that minus through. We got our long f of x plus h again. Then when we distribute the minus through, the minus gives a plus 4x squared. Then we get a minus 4x. And then we get a plus 4. And once again, pretty much everything that I have in pink here should cancel out with something over here. Everything on the subtraction part should cancel. And the 4x squared cancels with the negative 4x squared. Negative 4x cancels with the 4x. And the 4 cancels with the negative 4. And we are left with these three terms here. We got negative 8xh minus 4h squared plus 4h. And now to finish up, the last step is to finish the fraction. We divide by h. So we take our numerator, divide by h. Our simplified numerator is here, negative 8xh minus 4h squared plus 4h. Divide by h. And this is one where you can't just cancel out an h. You want to factor h out of the top and then cancel. Right, but we can factor an h out because we got an h here, we got an h here, and we got an h here. We got it in all our terms. When we take an h out of the first term here, we're left with negative 8x. When we take an h out of the second term, since we have two of them, h squared, we got negative 4h. And then the last term, when we take the h out of 4h, we're just left with 4. And this is where we can finally cancel because the h is out front being multiplied. So we can cancel the h's. Right, always remember that you can't cancel when you have pluses and minuses. You should wait, make sure you can factor out, and then cancel. But then what's left? Well, it's a lot more complicated than our last answer. It's not just a number, but that's okay because that is our answer. Negative 8x minus 4h plus 4. Unfortunately, that is as simplified as this gets. It's not going to be just a number, but that's okay. Right, and that is this section on average rate of change and difference quotient. You won't see things with third powers because that takes an extremely long amount of time. You won't see fractions in this section, besides the one in the formula. So that's it.